Hello everyone, my name is Sean Hendricks. I'm here on the SIGGRAPH show floor with Thinkbox Software, and I'm here with Chris Bond, the founder and CEO, and we've also got Bobo or Borislav Petrov, depending on how you might know him, who is going to be taking us through some of the demos of their stuff. But let's start with Chris. Could you tell us a little bit about Thinkbox and what it is that you guys do?
Sure. Well, Thinkbox Software is a visual effects software technology company. We create plugins and tools for artists so that they can create massive visual effects sequences or render tens of thousands of frames on the render farm.
Now, I know you guys have got a fairly long history going back quite some way. Could you tell me a little bit of how you got into this industry and kind of what got you to where you are?
Sure. Well, yeah, I started a company called Frantic Films, and we worked on about 42 feature films over the period. Our first one was Swordfish, and the last film that I supervised was Avatar. And during that time period, we created a lot of in-house R&D. We decided that there's specific things that we needed to do really well and focus on for our skill set, and that was primarily visual effects, massive point clouds, huge explosions, that kind of thing. So we've taken all of that IP and created a software company and focused exclusively on delivering that technology to our clients.
So then really, certainly it's what I've seen in watching what you guys have been doing the last few years is everything you do is very much production tested. It's all been proven in very, very heavy productions. So what's some of the stuff you guys are showing this year? What are the big kind of ticket items for you guys?
Well, we've got a number of tools that we're showing this year. The main theme, I think, is freedom of choice. We're multi-platform, cross-OS, so we've got a number of our tools that have existed in production, like Frost is a particle mesher that we've used for fluid simulation and dynamics, and that was in the Max world. And now we brought that to Maya, along with XMesh and Krakatoa, and that's across Linux, Mac OS X, and Windows. And we've really tried to build a tool set for our artists so that they can work where they want to work and how they want to work and be flexible in moving their data around between the systems. So in Krakatoa, Frost, and XMesh, we have interoperability between all of the tools, and they all plug in really well together, and we have formats like PRT and XMesh that move across all of these different platforms.
Perfect. So why don't we take a look at some of the tools you've got going?
Sure. So I'm going to turn this over to Bobo, and the first thing you're going to see here is Frost in Maya.
Yeah, this is the newest member of the Maya plugin family. We had Frost for many years. In fact, it was the first plugin that Thinkbox released as a new company. And what we're seeing right now is a point cloud of 6.8 million points, which was LiDAR scanned from a car. And I'm showing only 10% of it in the Maya viewport. I can go and show all 100%. It will become a big, wide blob. And in this scene, I also have Frost, and I have instructed Frost to actually mesh this. I'll just enable it in the viewport. It loaded the particles, 6.8 million particles, and then the next process is the actual meshing. And we can watch the performance. It's mostly at 100% until it's done. And now it's passing the mesh to the Maya viewport, which will take a while. And here we go. This is the frosted mesh, which is the principle of isosurface, so it's like a blob mesh, so it's watertight. It can be even 3D printed. And it could be used, for example, for as a reference for retopologizing, or probably even rendered as it is. Another thing that we have, one of our customers gave us a fantastic scene which was simulated in Naiad and had 180 million points of a waterfall. And I'm going to load this scene in Maya so it can mesh in the background. Here it is. And in the meantime, I will switch to Max and show you that same waterfall in Krakatoa while Maya is meshing. I have split that sequence to 10 pieces, 10 partitions of 18 million points each. And right now in the viewport, I'm showing only 1% of the first partition, so it's relatively fast, about 180,000 particles in the viewport for quick iterations. Now I can go and render all 180 million particles, and since we are loading these particles from Fusion IO card, I'm going to show you later also the log when it finishes, but right now it's loading 180 million points from disk, and it finished loading. And we are going to see it took 5.6 seconds to load 180 million points from disk, multi-threaded. This machine has 32 threads, 16 cores, and all of them were busy processing data. And now the data is being further processed by illuminating it, so we're doing the lighting pass, and after that there will be the drawing pass, and 180 million particles are going to end up in the viewport. I'll go and check what is going on in the background. Of course, we're kind of taxing the system now with both frosting and Krikatoa rendering, but so far it's doing well, and I can see my Maya has already loaded and meshed those 18 million particles that I promised. This is portion of that waterfall that was given to us by Evermotion. It's a Polish company that does lots of effects and also teaching and providing information to people. Actually, we have a video of this, but in order not to waste time, at this point I think I should move to our further demonstrations, and if you want, you can go to thinkboxsoftware.com and take a look on the Frost and the Krikatoa in production pages. We have posted lots of videos, including the waterfall and a few examples for really good
for the waterfall. Can you?
Yeah, I can find it. This is the animation. I'll actually forward a little bit more so I can see. These are the 180 million from different points of view, rendered in Krikatoa with true lights, and this is the actual whole sequence, starting from the beginning with the NIAD simulation, going down and jumping off cliffs. There is also a matte object that can be used in compositing to create the background, and you're going to see it a little bit later. We have also the frosted version of this. Unfortunately, the data amount for this was about 1 terabyte, and we got only the last frame for demo, which is 4 gigabytes. But the video actually shows all this, and in the Frost version of this, I'll also jump a little bit ahead because here it is. This is the version of the same 180 million particles falling down, have been rendered in V-Ray, and this is just the mesh, grayscale, no special effects on top, just the pure meshing. Supposedly on a quad core with hyper-threading machine, i7 or whatever, just typical workstation. The last frame with the 180 million particles, the frosting took about 7 minutes.
It's not bad.
It was, in fact, it was a challenge. People on Vimeo said, okay, you rendered that in Krikatoa, now show us a mesh.
Yeah, exactly.
And we actually called the guy and said, hey, do you want to try Frost and see what will happen? And he was really happy. This is the actual, in the animation, he showed a picture of the max viewport, so I can see that it contains 136 million polygons. All right, so let's move on. I'm going now back to max. We finished rendering in 55 seconds for the 180 million particles, and we got some bluish and white color based on the velocity. And we saw that the loading from disk, normally it would take about a minute, I think a minute and 17 seconds was the time with single-threaded loading from a hard drive, but with the Fusion IO card is like there. So another thing that we're showing this year is a new feature in our deadline submitter for 3ds Max. We have this car here, and we have already rendered this car at 10K for large format printing, and this was rendered in Mentor Ray, and this is the 1:1 size. So it's relatively huge, and it took, on a single machine, it took 35 minutes to render. The idea is that in some cases when you're rendering like 10K or 16K and so on, and you want to change some small detail, you would like to render only a region and superimpose on top of your previous rendering in order to update just that and get fast iterations. But we had customers that said, yeah, we know that Max has a region rendering, and pretty much all renderers and all 3D applications nowadays allow that. But what we want to do is use Deadline to get multiple regions defined at once and submitted to many machines at once, and then combined together in order to get a really fast iteration. So I'm going to launch the Deadline submitter. And in the Deadline submitter, we used to have a feature that was called tile rendering that did pretty much that, but it was a regular grid, and you always had to render all the tiles, and then you could re-render some of the tiles and combine with the previous ones. And it wasn't flexible enough for some of our customers. So I'm going to switch to this tile rendering dialog, and I can start creating my own regions. For example, I can select this wheel and say add a new region and fit it to that wheel, or there is another wheel there and say another region and fit it there, and I can keep on doing that. I can even go and say I want to change the color of those tires, and what I'm going to do is I'll open the material editor of Max. I'll replace the tire color, so now the tires are brownish, and then I can use the select by material, and then just open this option here that says create from scene selection, say yeah, replace everything, and now I got all the 4 wheels automatically highlighted, and I can keep on adding. Those regions can be resized, they can be snapped to each other. In fact, this one I don't even want. But I can just go and delete it. I can select them individually. I can select them multiple selections. I can copy them, for example, clone them up. So it's basically a system where I can cover your whole screen with regions, or just say, okay, the logo changed from black to red. I'm going to create a region here. The mirrors will be black instead of the body color, so I'm going to create regions here, and so on. And then I just hit render, and it sends to deadline, and each one of those regions gets rendered by a separate machine. But if I want to add more detail here, for example, there is lots of reflections, probably even motion blur, I can very easily select this region and just say, I want this to be split 3 times 4, and each one of those sub-regions will be sent to a separate machine. So I can resize this region very easily, but the number of machines remains the same, and it automatically sends it, goes, and then when it comes back, you get only those regions already rendered over the previous image, and you can be very, very productive in a fraction of the time. Probably takes 2 minutes to, if you have enough machines, to update that 35 minutes rendering with new details here and there. So this is a big time saver for our Max users, and we have every intention to actually implement the same thing for Maya and Softimage and all the other 3D applications and renderers that we support.
Very excellent.
So yeah, that's one of the highlights. Yeah. And my favorite project this year is called Stoke. And Stoke was actually, we started development in January this year. 2 weeks later, an early alpha version was actually used by Pixomondo on After Earth, and we even had a presentation here. The boat looks gorgeous, but it was done with software that was 2 weeks out. I don't know if it has ever happened, but it was pure genius that it actually worked that well. And now at SIGGRAPH we're actually announcing Stoke 2.0. And Stoke originally was based on Ember technology, and Ember was a product that we were prototyping last year and showed at SIGGRAPH, and people were really happy about it. It's about fields, editing and manipulation. That means particles and voxels and mathematical functions, driving particles around and so on.
Yeah, so
I'm going to show the simplest example possible that hopefully will explain to you what we're trying to achieve with it.
Yeah. Why don't you open it up and I'll explain a little bit. So it's not quite a particle system. It's a tool set that lets you sample and build other particle systems and mix them from other sources. So the classic demo that we did last year was we took a simulation from a fluid sim and a fire simulation from a different tool set, and we mixed them together, and we had the water putting out the fire. And they came from completely different sources. So there's a number of things that you can do with it. You can sample which is what Bobo's going to do. He's going to sample a very simple particle system and then enhance it and multiply the number of particles by, millions. So and completely change the original source. I'm going to turn this back to Bobo.
Yeah, I'm doing this demo using the spray particle system, which you probably know was in 3ds Max 1.0 in '96. So nobody's using that anymore.
It's never seen an update ever, that particular one.
Yeah.
Yep.
And it's kind of interesting because this is the most basic demo of Stoke, but it actually shows how you can revive existing tools. I'll have to disable my region rendering here because it popped up in the viewport. But I have this particle system. It emits over 30 frames, 100 particles, and then nothing. I have created a plane underneath that will represent my emitter. I'll select both objects, and I'm going to create a Stoke object. And this Stoke object automatically says, hey, the plane looks like a feasible emitter, and the particle system can also be used as an emitter, but I'm going to skip it for now. And the actual spray will be sampled. We take the velocities, put them on a grid, and then drive our new particles. Right now we'll be emitting 100 particles per frame. And when I do this, my particles are following exactly the same motion, but when those driving particles die, my particles start gathering on top, and what I can do is I can just delete them procedurally, and I can even change when exactly at what age they get deleted and so on. But now I have something that is kind of following the same animation. I can easily steal from the emitter any relevant channels with absolutely no overhead. So in this case, I'll be stealing the UV coordinates. And I'm going to hit simulate again. This will resimulate, and I'm going to show them as, I'll show the velocities, and I'll show them in the texture color. So now we're seeing lines, and they are following, but this is still pretty much doing the same boring thing that the original system was doing. What I can do, though, is there is a checkbox that says create fluid motion. And what happens in this case is we take those 100 particles, put them on a grid, and after we put them on a grid, we get a velocity field, which is not really a fluid, but we can reprocess it to remove the so-called divergence. That means we make it uncompressible fluid. In every point in space, the amount of fluid that's coming out has to be equal to the amount that's coming in. And when we do this, and especially if I use a smaller grid, like a 5 size, and resimulate with that, I'm getting something that looks more like a fire burning. And I'm going to add, I'll create 1,000 particles instead of hundreds. I'll say preview on every 5th frame so I can see how it's going. And now I have, from that mundane spray that nobody uses for anything, I actually got something that looks more like a fire simulation. But as you probably know, the spray can be very easily deformed, for example, to a spline, something that's quite tricky with particle flow. Following a spline there is creating forces along the spline, and it's kind of tricky. So I'm going to create some crazy curve here and tell through the old path follow space warp that my original particles will be following this curve. That means all I have to do is select the old system, bind to this space warp. Oops, I think I picked the wrong system there. Did I? Yeah, now it's good. And I'll use the offset splines option. So I have those particles following around. All I have to do is go to my stoke and tell it to try to follow those. It looks like I did the curve a little bit too curvy, so it's kind of confused here. And what I can also do is I can disable that deletion, so my particles will continue living a little bit longer and following around. And then when that finishes, they appear there. And I can keep on adding. I can go and take, for example, a force with turbulence, like the wind, add it and start additionally deforming the whole thing and so on. So this is the simplest example of taking one particle system and driving another one. And you know, Krikatoa needs hundreds of millions of particles. And we take as sources VFX, we take particle flow, we take all the other particle systems and all the forces that exist in Max. And VFX we simulate actually about 10 times faster on an 8-core machine than with VFX follow inside of particle flow, thanks to multi-threading and
we're asynchronous, so while we crank up the particles to, you know, 1 million.
I have a special scene for that.
Okay, great.
If I open this scene, in this scene I have 2 stokes, and the first stoke is creating small those yellow particles, very few particles, actually only 5% of the whole simulation. And I have a second stoke, and this second stoke will be following with fluid motion, the motion of this. If I start simulating, you see that plasma, but it's simulating really fast. So what I'll do is I'll let it simulate a lot of particles. And in addition, on top of that, I'm going to add a magma modifier, and in the magma modifier, I'll tell it to also show me that same color. So I'll say, okay, I'll be using the color channel as the output, and the input will be texture map. So the texture coordinates, which I'm stealing, so these blue colors. That means I could prepare my render. I don't even have to do that, but I'll go and prepare the force additive and try to see what happens here. And in my stoke, I will start simulating from the beginning, trying to get 1 million particles simulated and written to this. Okay, I'll go to 10 million.
Excellent.
I start
particles, that's a good start.
simulating. I started simulating now, and it's actually simulating, and now I can stop it at any point. While it's simulating, I can resume after that. I just don't want the preview to be running at this point. I'll say resume, and while the simulation is running, I can actually navigate my viewport, and I can open Krakatoa as a renderer, and I can hit render and render what is currently being simulated. That's a little bit too dense, so I'll go down with these settings and zoom a little bit closer. And in the background, my simulation still runs and saves PRT files in parallel on multiple threads. Because I have many cores here, it can potentially simulate on, let's say, all 32 threads, and 16 of them are able to, in parallel, save files to disk. So I'm completely able to actually continue being creative. In fact, after the simulation finishes but the saving continues in the background, I can open another Max scene and do something else, and my simulation will still finish in the background thread asynchronously and save all the files. Now, this is a big game changer because there is not a single moment where you are not creative inside of Max. Stoke lets you work, start simulating, take a look at the results, even render them while the simulation is running. If you don't like the results, you stop, change them again, start simulating again. If you happen to like it, you just let it finish and do something else in the meantime. When it's finished, you pass the data to the next guy to render in Krakatoa, and you never waste a cycle.
And I know, just to kind of comment to people at home, I first saw the Stoke stuff and everything that you guys were doing last year, and it was actually a moment that kind of blew my mind on simulation, because everyone's kind of used to this whole idea of I'm going to set up all the constraints in my simulation, get everything going, I'm going to hit calculate, walk away. And now the sudden concept that a simulation that was done in the past can suddenly be kind of brought back up, reused, repurposed, set in an entirely new scene without having to do all that original recalculation again. I think I spent a good 20 minutes just trying to wrap my brain around what would that mean in a visual effects world.
What it means is that normally in a simulation, you're throwing the watermelon against the wall 100 times till you get the version you like. What it means is you throw it against the wall once, take that, sample it, and then alter it in sort of post-simulation mode. And then if you like it, you can mix it with other ones. So when the director says, you know, I like these two sims, but I want 50% of that one and 50% of that one, which is almost an impossible task, you can actually do that here. You can actually take the two sims and blend them so that they get the forces of 50% of each, or 50 sims and 10% of each, or whatever you want.
So what it really is giving is kind of the panacea of a directable simulation for all intents and purposes.
That's right. In one of the demos, we don't have time to show right now, Bobo actually creates a mushroom cloud from splines, and we target that shape, so you can art direct your simulation.
Yeah, that's, I don't know how many times I've heard people in the VFX world, I just want to be able to direct this, now I got to figure out what force to change to get that simulation. If you can just direct it, that'd be awesome. All right, so what do we have now? Anything else here?
No, I mean, this was the basic presentation of Stoke, and we covered Deadline and we covered Frost in Maya, and we also have, of course, Frost in Max, but everybody has already seen that, hopefully. So I would say those are the highlights.
Perfect. All right. Well, thank you very much, Bobo. I really appreciate you showing this stuff to us. And Chris, again, thanks for having us over to take a look at your stuff.
Thanks a lot.
And everyone, we'll see you at the next interview we do. But again, thanks to Thinkbox Software. I recommend you go to their website, check out the tools. There's a lot of people out there who haven't realized these tools are there, and they are truly awesome. It's amazing what you can do and how much time can be saved in the world of visual effects using the stuff these guys have created. Thank you very much.